The group 1 elements, which are known as alkali metals, are a bit different from most other metals. They include lithium, sodium, potassium, rubidium, cesium, and francium. Instead of being strong, having a high density, and having a high melting point, like you expect of a metal, the alkali metals are in fact relatively soft, with low densities and low melting points. They are also much more reactive than other metals, and react vigorously with water, oxygen, and group 7 elements such as chlorine, as we'll see later. As you go down the group, the elements become even more reactive, with cesium being so reactive that it can ignite spontaneously at room temperature. Another trend as you go down the group is that the melting points and the boiling points decrease. Now, an easy way to remember this trend in reactivity is that common table salt, which has sodium in it, doesn't just suddenly catch fire as you sprinkle it on your potatoes, whereas cesium probably would. Now, a big part of chemistry is explaining the properties and trends that we see. For example, how would you explain the fact that alkali metals are so reactive? Well, if you remember from our electron arrangement video, which we'll link down below, all atoms want to have a completely full outermost shell in order to be stable. And because the alkali metals are all in group 1, we know that they all have one electron in the outermost shell. So in order to react and be stable, all they need to do is lose that one single electron, which is pretty easy because there's only one electron to lose. And because they lose a 1 negative charge, they'll become a 1 positive ion. What about the trend that we mentioned though? That they become more reactive as you go down the group. Well, as you go down the group, the atom's radius gets bigger, and so the outermost shell gets further and further away from that positive nucleus. Now, as this positive nucleus is the only thing holding the outermost electron in place, the increased distance weakens the attractive force between our positive nucleus and that outer negative electron, meaning that the electron can be lost more easily, increasing the atom's reactivity. Remember, the term reactivity isn't anything special. It's just related to how easily atoms can lose or gain electrons, and so react with other atoms. Because alkali metals can lose their outer electrons so easily, they almost always form ionic compounds with non-metals. We'll take a closer look at ionic compounds in another video, but it's basically where a metal atom, like sodium, donates an electron to a non-metal like chlorine, so that both of them have full outer shells. And because these two atoms are now oppositely charged ions, they'll be attracted to each other by electrostatic forces, which we call an ionic bond. And so together they make an ionic compound. This particular example of sodium chloride actually happens to be common table salt. But regardless of the alkali metal used, the ionic compounds are generally white solids, and they tend to dissolve in water to form colourless solutions. So now that we've covered alkali metals in general, we need to consider how they react with water, chlorine, and oxygen. When an alkali metal is put in water, it reacts vigorously to produce a metal hydroxide and hydrogen gas. For example, sodium plus water will form sodium hydroxide plus hydrogen. As we mentioned earlier, the metals become more reactive as we go down the group, and so the reactions will release more energy. In fact, from potassium onwards, so much energy is released that it ignites the hydrogen gas that gets produced, which we can see in the form of flames. Group 1 metals also react vigorously when heated in chlorine gas, and in this case, they form white metal chloride salts. So sodium plus chlorine would form sodium chloride. And again, the reactions will become more vigorous as you go down the group. When alkali metals react with oxygen, they form metal oxides. However, the type of oxide they form will depend on the particular metal. For example, lithium plus oxygen forms lithium oxide, Li2O. just like sodium plus oxygen, forms sodium oxide, Na2O. However, sodium and oxygen can also react to form sodium peroxide instead, which is Na2O2. Meanwhile, potassium can react with oxygen to form either potassium peroxide, K2O2, or potassium superoxide, which is KO2. Now that's quite a lot to remember, and you don't really need to know why these particular compounds form. So the best trick is probably to just put them on some flashcards and practice them whenever you need to know them for exams. If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.